Welcome to Chips and Salsa, where we talk security and intel. I'm Jerry.
CRob. Hey, Jerry, do you like to use the cloud?
Oh, I sure do, CRob, but I only like my clouds to be secure and rooted in trust.
Me too. And Intel is a big fan of secure clouds too.
Yes, I did know this, and we've talked about Intel TDX and SGX in previous episodes. Those are technologies collectively, along with attestation services. They're part of Intel's confidential computing portfolio.
Yeah. And Intel is also part of an industry group called the Confidential Computing Consortium that's focused specifically on the challenge of protecting security and confidentiality within cloud environments.
Yeah, that's cool. And our guests today are here to talk about that collaborative group. So let's jump in.
Yeah. Mike and Dan, welcome to the show. Could maybe you gentlemen introduce yourselves and then talk a little bit about what the Confidential Computing Consortium is all about?
Yeah, sure. Thank you. So I'm Mike Bursell. I am the executive director of the Confidential Computing Consortium, which is the industry body promoting the use of confidential computing and open source around it as well. And I'm joined by my esteemed colleague, Dan.
Hi, I'm Dan Middleton. I'm so excited to get to come on Chips and Salsa. I operate as the chair of the Technical Advisory Council of the CCC, and we're the part of the CCC that's focused on projects and how we engage in the rest of the technical ecosystem and how we grow our open source community.
Nice.
Yeah, and I would say that we loads of the stuff we do is on the technical side. Although we're about promoting the use and so there's kind of outreachy marketing stuff, we have so much engagement from the members on the technical side, and Dan steers lots of that. It's not just the council which meets every 2 weeks for 2 hours. You have a lot to talk about, but also we have a number of special interest groups, which I suspect that Dan would love to talk about at some point as well. So there's a lot of technical stuff going on from across the membership.
Nice. Well, welcome to the show. Let's start by asking the question, why was the Confidential Computing Consortium created in the first place?
Yeah, sure. So I was there almost from the very beginning, actually. So in about July 2019, I think. Yeah, July 2019. Some folks from Intel and some folks from Microsoft were talking about how to promote this new technology. So the technology was as SGX, Trusted Execution Environments. SGX was the earliest one from Intel, and they approached IBM, and I was working for Red Hat at the time, which had recently been acquired by IBM, and I was chief security architect in the office of the CTO at Red Hat, and we were doing a bunch of what we now call confidential computing, and in fact I co-founded a project, an open source project called NARCs, and so I said, yeah, this is actually really good timing. Let's gather some other folks together from the industry and make this happen. So Red Hat was one of the founding members of that, and come on sort of 4 years, we've now got all of the major chip vendors. So that's Intel, but AMD, NVIDIA, ARM as well. We've got Huawei, we've got TikTok, we've got lots of other big players in the industry as well, and lots of startups and sort of academic and getting some interest from government folks as well. So it's acting as the sort of industry body for confidential computing, which, as I said, is around trusted execution environments, which is this hardware-based, a tested way of isolating applications and their data from the rest of the host. We're part of the Linux Foundation, so it's a safe place to have those conversations, and it gives us loads of links to the bigger open source ecosystem. So that's kind of how it started about 4 years ago. And I've been involved throughout, and about April last year, a startup I'd been working on failed, and I ended up coming and being the exec director, which is lots of fun.
Nice.
Have I missed anything, Dan?
No, that was really thorough, but I'm sure we'll explore other facets between the points that you brought up.
Yeah, absolutely. So Mike mentioned a bunch of the participants and kind of the personas within the CCC. So, Dan, from a technical perspective, why would somebody want to participate in this group? What do you get out of it, or what are they trying to do?
Yeah, so a lot of the people who are in the CCC are participating because they're working on confidential computing and they get to collaborate with people that they wouldn't maybe otherwise get to do. So
Hmm.
Mike mentioned that we've got all the major chip architectures represented in the CCC. A little later today, I'm going to meet with my counterpart at AMD, and we're going to be talking about some of the objectives that we have on the Technical Advisory Council.
Hmm.
And the Linux Foundation gives us this safe place to interact and collaborate. We also have people that are interested in security that maybe aren't currently working on confidential computing.
Hmm.
There's a number of discussion groups that we have that you can just show up and be a fly on the wall and learn if that's something that you're interested in. Of course, if you are already developing open source, we'd love to support that within the CCC. Anything that's relevant for confidential computing is welcome and accepted within the CCC.
Nice.
Yeah, so an example of some of the collaboration things that happen again under the technical umbrella, let alone the marketing umbrella, because we can come to that. But in terms of the technical side, we've got stuff from governance, risk, and compliance, really quite high up the stack in the business side of the house, working about how that works, talking to regulators, talking to standards bodies, trying to understand how confidential computing technologies can help in that sort of space, all the way down to we have a group specifically on the Linux kernel and how to get appropriate architectures upstreamed and code and patches upstreamed into the Linux kernel, because the Linux kernel community is a very special one and needs to be addressed in the right way. And so this is a great place for these competing companies, but who want the same thing for the industry to work together in a safe place and to do that. And the example that we had just had from Dan's a really very good example of that.
Uh-huh.
Yeah, and I like you bringing up the GRC SIG, the Governance, Risk, and Compliance SIG, because that's led, by the way, by somebody who works for JP Morgan. So people there who are practitioners and adopters, they bring really important requirements to those of us who are working on creating the technology. And there's this great feedback loop where, if something's useful or not useful, we can accelerate or deprioritize that kind of work, and we just learn from each other. So learning what's important within a bank to protect, what sort of compliance requirements that they have that we can help support by protecting the use of data in execution is just really helpful for all of us.
So one of the things I really enjoy about the CCC is the breadth of industries and sectors are involved and who want to be part of the conversation. I led a Birds of the Feather session at RSA conference in North America just recently, and we had a bunch of people from all over the different sectors. My favorite one was we had a guy from pest control. And they're worried about personally identifiable information, PII, and data privacy. Because, if you're a business or a residence, you don't want people knowing, what pest controls issues you've got. And if these folks are interested and the banks are interested, well, everyone in between should be interested. I thought that was a really good example.
That's wild.
Yeah. So
well, no, hopefully not too wild, but yeah.
You guys kind of been hitting on some of the work that the Confidential Computing Consortium does. So, why don't you tell us about some of the projects that the audience may be familiar with?
Yeah, I would love to, because projects are kind of our heart and soul as an open source organization. And Mike mentioned one of the reasons we recruited him in was that he was one of the founding personas behind the NARCS project, which I think is our first or our longest lived project.
It was
in
the
the
first.
CCC.
Yep.
It was the first. Okay, thanks, Mike. I thought you'd catch me on that if I was wrong. Another project that people might be familiar with is Gramming. Now, the idea with confidential computing is that you're going to wrap some execution that's important to you in an enclave boundary, and that has some additional security properties that you wouldn't have in your normal environment. If that enclave, though, needs to make use of anything out in the operating system, it kind of has to open a little door, and that's where the risk always comes, is what you put into the enclave and what's coming out of the enclave, wherever you have one of those boundaries. So what projects like Grameen do, and also Grameen's cousin project called Oklum, they provide what's called a library OS, or we call it a libOS. And it's like you're packaging the entire operating system as a library, except that it's not really the entire operating system. It's just often the most common calls, so that we can limit the number of times that your secure enclave needs to exit out into something that might be a less secure environment.
So I think those are some really nice examples. The other ones that spring to mind for me are, we have a number of projects in the attestation world. So attestation, for anyone who knows about confidential computing, is a vital part of the overall system. So basically, it allows you to be sure that what you're running has been properly set up and is cryptographically secure. You've got those assurances carried through to you. But how you manage that is fairly complex. And so we have a number of open source projects to do that. And another one that I think is really interesting is there's one from Samsung called Islet, ISLET, which is aimed at sort of edge devices and smaller devices, currently mainly in the ARM realm. But it's not just server workloads we're looking at. It's across the computing spectrum of compute, really big to really small. And that's, we want to encourage the CCC, the Confidential Computing Consortium, as a place to be a home to those sorts of projects.
I think the ARM realm comment was an inadvertent pun, and I appreciate that. For those listening who don't know, ARM realms is one of the security features of the ARM.
Oh, did I say realm without meaning to say realm? Yes, okay, right. It wasn't completely unintentional. Nice.
That's hilarious. Could you maybe share with us, I think I understand, but maybe for our audience, why is confidential computing important for places like the cloud, or if I'm working in AI, or if I'm even thinking about my software supply chain? Why is
me. Okay, so the cloud's fantastic, right? To be able to put stuff out in the cloud and use that capability without having to own all of the infrastructure myself and manage it myself. Brilliant. The problem is, it's kind of okay for my holiday snaps, but it might not be so okay if I'm a bank, or I'm a pest control company, or I'm an insurance company, or a pharmaceutical or healthcare, where I really need to be able to protect my data. And however much I trust my cloud service provider, my CSP or my hailer, is that trust enough at a sort of contractual process level for my shareholders, my board, my CISO, my CFO, my regulators, to be sure that it is entirely safe from exfiltration, or from being messed around with, or however people attack that data, or even those processes themselves. So the answer is, without confidential computing, without hardware-based capabilities, it is impossible using standard computing to protect your applications and their data from the owner of a machine, by which I mean someone who has admin privileges, or kernel access, or hypervisor access. The way virtualization works allows them to look into and mess around with whatever it is in that system. And that's a real problem. So what confidential computing does is provides an isolation away from the host, away from the kernel, away from the hypervisor, away from the admin, so that even if that machine is compromised, or you have a bad actor, it is isolated, and you can have cryptographic assurances based in the hardware that your data and your application is safe. And that's a huge thing, whether it's on the cloud, whether it's on-prem, because you're worrying about, internal threats, insider threats, or whether it's on the edge. You've got something sitting in a data center in a stadium, or on the top of a pole, a telegraph pole, whatever it may be. Providing that isolation away from the owner of the machine or the operator of the machine, whoever has access to that machine, is something that you have to have, because you can't do it with standard virtualization, with containers or standard VMs. So we work, confidential computing allows you to work with those technologies to provide that isolation and that separation. And that's really important for all sorts of privacy use cases, and lots and lots of interesting cases around collaboration with other companies or other organizations, and also for AI, which I suspect we're going to want to talk about in a bit.
Sure, I would love to talk about AI. And I'll just kind of dovetail on Mike's description that when confidential computing was first becoming popular, it was a great answer for companies that wanted to move workloads to the cloud but didn't want to have to trust another company. Sort of a second level understanding of confidential computing is it can help you reduce the actors that you have to trust in general. And so it's also valuable on-prem. So if you operate your own data centers, you operate services that you don't want to or can't for regulatory reasons move out to a cloud provider, confidential computing helps reduce the number of insider threats that you have. Now, where does this connect with AI? Increasingly, these kinds of workloads require accelerators. And so you might be using accelerators in your cloud deployment or in your on-prem environment. And this kind of goes back to when I was talking about gramming. You have a secure environment, you have a secure enclave, and you want to bring something else into that from the operating system. Well, this was always a challenge with accelerators like GPUs. You have to attach another device. How do you secure that device? So we have a whole slew of standards that are coming together now, mostly through PCIe and DMTF. And if you don't know those acronyms, it's not important. If you want to use an AI accelerator, though, we have a project at the CCC called SPDM Tools, another acronym. It's Secure Protocol and Data Model. As an end developer or an adopter, you probably aren't going to deal with that project directly, but the companies that are making hardware are going to make use of that so that we have a secure link in between a GPU that can attest to its security state and the enclave that you have written, or the secure or confidential VM that's operating. So they can both mutually attest if you want to go that model. And then you can present the security state, which is really what an attestation is. You can present the security state of that conjoined environment out and decide whether or not that's something that you want to trust.
Yeah, I have a really good example of that as well. I was at a major investment bank, sort of multiple billions and billions of billions, one of those ones that everyone's heard of, which I obviously can't mention. But they were talking about AI usage. This is just a couple of weeks ago. And there are two different stages in AI, right? There's the AI training side, and then there's the actual inference engine when you're using it. And they've got problems in both sides because they really want to do this stuff, but they need to protect it. They need to protect it from insider threats or from cloud threats. And first of all, they want to be in a position where they can be sure that what is being used in the training is what's being used for the inference. And confidential computing can help with that, and it can protect the actual training data as it's being processed. So that allows the model to be created, which they can be sure is A, what they think it is, and B, it has the confidentiality they need. So that's great. That's step one. Step two, when they're actually using that training model, they want their analysts to be able to type queries into this thing, or speak to whoever brains, I guess they do it, brain interfaces one day. But however they interact with it, they want to make sure that those queries are themselves confidential, because you don't want your competitors knowing, who might be a merger or an acquisition target, or how much you're looking to spend, and you don't want the output from that also to be shared. So the confidentiality of the queries and responses is also important as well. So both at the training and at the inference stages, having that confidentiality and the integrity of the data and the assurance that what you're doing is carried through is really important and really useful. And confidential computing allows them to do that in ways they just couldn't before.
Awesome. So Dan, maybe a question for you. What's Intel doing with the CCC to drive confidential computing further?
Well, we've supported a number of projects there and a number of the SIGs. So we've mentioned a couple of these already, the governance, risk, and compliance SIG, the kernel SIG, and the attestation SIG. And then also within the Technical Advisory Council, there's things that we do that are contributions, but we're also there learning like everybody else. We were really lucky a couple weeks back at the Technical Advisory Council to get a tech talk from a Googler, Deanna Glaze, and she talked to us about how Google is working on their secure software supply chain to help support how they use confidential computing. And so this is a great insight that I get to learn about how Google does things that I wouldn't have been able to learn if I wasn't part of the CCC. And it also just touches on one of the other huge topics for us right now, especially after things like the SolarWinds attack, of how do you trust the software that you're running? With confidential computing, we can put a boundary around something so that it's harder to attack. But if what you put inside that boundary is already corrupt, how do you deal with that? So we want to help make sure that the people that the software that people load in is secure from the get-go. And so being able to have a traceable supply chain where you have built that software with trusted components, and we've just got attestations everywhere. So this ability to have a cryptographic measurement of what you're running, what you've built, and have that all tied together end to end through your whole supply chain, that's one of the huge goals for us in confidential computing.
Yeah, I'd add there's other stuff that Intel is doing, not just on the technical side, but also on the promotion and outreach, because this is technologies that not everybody knows about yet, right? So we are part of the Confidential Computing Consortium, and part of the reason that you can join it, particularly something like a startup, is we hold events, we sponsor events, we attend. For instance, we attended an RSA conference I mentioned, and we had a booth there. And any of our members, even a startup, can come and help staff that booth, have demos up about what they do, as well as demos about the open source projects as well. We invite members to be on panels or to speak at conferences where we're sponsoring or where we've been approached for speakers. So we've got a number of areas where we're doing exactly that. We have our Confidential Computing Summit coming up shortly in San Francisco. And Intel, I know, is going to be a big presence there, but as will lots of other people in the ecosystem. And so being part of the ecosystem and helping drive that is certainly part of what Intel and other members are very much part of pushing.
Thanks for recognizing that, Mike. One of the other things that I get to do with Intel wants me to bring Intel values into the open source work that we do. And one of the things that I'm really proud of for us at the CCC is we've always been a really inclusive organization. Everybody's welcome. It doesn't matter your level of knowledge of confidential computing or security. It doesn't matter if you work for a big company. It doesn't matter if you look like other people. Everybody's welcome. Stop in, see what you see at a meeting, check out a repo, maybe file an issue if you can't get something to work. And I hope you feel really included in the CCC.
That's really important. From my point of view, diversity is hugely important in security generally, because we need people who think differently, because we need to be able to defend against people who think differently, right? So if we don't have a broad set of experiences and backgrounds and thought processes and views of the world, we can't be in a position to defend against the bad folks who are going to use all things at their disposal, right, to get to us. We need to think in as many ways as possible. And it's not just enough to have someone from the UK and someone from the US, right? We need everybody with lots of different backgrounds. And that's something that we're absolutely pushing as part of the CCC, and we're tireless as part of that.
I really like how you put that, Mike. In fact, one of the things we talked about near the beginning of the year when we were setting what goals we wanted on the TAC, was we kind of all realized that we had the same goal, that by working together as a community, we can help make the world more secure with confidential computing than we could do as individuals or as individual companies. And it was just a sort of a heartwarming thing for me to think that, hey, everybody who's here really cares about security and helping to protect everybody else from bad guys. And having that diversity of viewpoints really strengthens it.
That's awesome. I love it. Thinking better together, we're stronger. As we wind up, Mike had touched on the Samsung project, but are there any other projects that are kind of out on the horizon that get you really excited about kind of the next generation, the future of the consortium?
Yes, they are the ones that I don't know about yet, because people have just started experimenting, especially with these topics like AI and secure software supply chain. Uh, we have a lot of work that goes on in the companies that are already members in the CCC that are already open source, but they haven't maybe yet offered them as consortium projects yet.
Mhm.
But the level of creativity out there is really awe-inspiring. So we're looking forward to that.
Absolutely, and I'm aware of a few which may be coming along the line, which we just can't talk about yet because they haven't even got permission internally to make them open source and to provide them to the Confidential Computing Consortium and the Linux Foundation. But they're such a broad. People are thinking about using this stuff in ways that I haven't, and I'm sure Dan hasn't. And again, that's part of the diversity, right? The more people we have thinking about ways of doing stuff, the better it's going to be.
And some of it comes full circle because Anarchs, the first project at the CCC, was so forward-looking with WebAssembly. So if WASM is something that's exciting to you, there's a project that's already in the CCC, but also the WASM community is still growing, still evolving, and probably is near a cusp of growth itself. So I really like to see how things evolve, where you think, oh, this is a chapter that's already been played, but it comes back around full circle.
Awesome. Well, hey, we want to thank you guys for being on the show and talking to us about the Confidential Computing Consortium.
Thanks for having us.
And all the impact you guys are trying to drive. So we'll look forward to seeing some of this stuff come out later.
For sure. Great. Thank you so much.
Happy to have gotten to be invited onto Chips and Salsa. I've been watching it for so long, and I get to actually be on it.
Nice to have you here, Dan and Mike.
Yeah, thank you.
Wow. It was interesting to hear about the Confidential Computing Consortium and everything they're doing to help secure clouds and customers' data in hyperscale environments.
Completely agree, Jerry. And I find it really interesting how these groups form and how they operate, and they bring participants from across the industry together for that common good.
Yeah, it's great to see Intel's leadership in the CCC and other industry groups helping to drive a lot of these ideals.
Yeah, and I'm glad to be a part of it. And I think with that, we're going to call it a wrap today. And I'm going to go do some secure stuff in the cloud, man.
Hey, me too. Thanks for watching.